Kerbin is not as boring as some might think. It has some interesting surface features that reveal a violent past. One such surface feature is the big crater, which has a width of around 170 kilometers, which is quite wide for how big Kerbin is, because the Chicxulub crater that wiped out the dinosaurs here on Earth is around the same size. But how big would the object that formed this feature need to be to have created this crater long ago? If you know what kind of videos I make, then you will know what is coming. Math. It is a powerful tool and I'm going to show you what you can do with it. I'm going to start off with this equation that I found in the book that I used in a course on exoplanets. It allows you to calculate the diameter of any crater depending on a few variables. Note that this equation was derived empirically, meaning that people did experiments and came up with an equation that predicts the diameter of any crater well enough. The other variables in the equation are the density of the asteroid or meteor, the density of the excavated material, the surface gravity of the target celestial body, the radius of the asteroid, its kinetic energy, and the angle at which it hits the surface. But we already know the diameter of the crater. What we want to know is the size of our asteroid, which we can find when we know r. If we rearrange this equation so that it gives us r equals some variables, then we just need to plug in those variables and then we are done. So what are the values of these variables? The density of asteroids in general varies between 1400 and 5300 kilograms per cubic meter. But as everything in the Kerbal universe is about 10 times as dense, I will assume the same for the asteroid. The density of the excavated material will be that of Kerbin's crust. And possibly, if the asteroid hits Kerbin hard enough, it might even dig a bit through the mantle. So the density for this will be between 2600 and 3400 kilograms per cubic meter times 10. The surface gravity is equal to that of Earth, 9.81 meters per second squared. The angle at which the asteroid hits Kerbin is something we cannot really know. It can either be head-on or flying across the surface before it hits. So I will say that it can be between 10 and 90 degrees from the horizon. Then we have the kinetic energy that I wrote in terms of the mass and velocity of the asteroid. And then I rewrote the mass as density times volume. The latter depends on the radius and thus has been moved to the other side of the equation. Then we will need to determine the velocity at which the asteroid hits Kerbin. For this I will use the vis-viva equation. If you plug in the distance at which you want to know the velocity, the distance between Kerbin and Kerbal, and the semi-major axis of the asteroid's trajectory, then you will get the velocity at which the asteroid will be approaching Kerbin for that particular orbit. Depending on whether the asteroid originated from the Dres region or the Eel region, for example, the velocity will vary between 11 and 13 kilometers per second. Alright, that was quite a bit of information, but we just have to throw everything in the equation and we will get a range of the possible size of the asteroid. Not just a single value, because there are a few things we don't know exactly, like the angle. What we get is an asteroid that can have a diameter ranging from 14 up to 55 kilometers, with the best estimate around 35 kilometers. That best estimate is about 35% bigger than Gilly, and here is what it would look like next to the crater. And to see whether this result is realistic in any way, I found that the Chicxulub crater, which has a similar size to our crater, was formed by an asteroid ranging from 11 to 81 kilometers. So our estimate falls nicely within these bounds. And I must say that I'm quite happy that an amateurish calculation came to a reasonable value. It's interesting that the crater does not seem to have an official name. And when I asked you all, multiple people said they have been calling it the Great Crater. This sounds kind of plain maybe, but it's not as bad as Meteor Crater in Arizona. Yes, that is its actual name.